Now that we've talked about our radian measure and degree measure and how you can interchange between those, we're going to be looking at lengths of arcs and the area of sectors. So when we're looking at radians and degrees, we're talking about on a circle mainly. And that's what we're going to be looking at specifically within this whole unit. We're going to be looking at circles and how that information off of a circle or off of a unit circle can help us with trig functions and simplifying that based on our unit circle. So before we even get there, we had to go through our radian measure and degree measure, and now we're going to be talking about the length of an arc and area of a circle or of a sector, in which this is going to help us base our information later on. Okay, so the first thing that we need to do is to look at arc length. Ooh, horrible circle. All right, so I've got my circle here, and I want to find the arc when I have a 60-degree central angle. So this is going back to geometry a little bit, that you have to know that a central angle starts at the center. And so we've got this 60 degrees here, and I want to find my arc length from here to here and figure out how long that actually is. Okay. Also, my radius, though, you need your radius length, is 3 inches. Okay. So how is this going to affect us? Well, we know that our whole circle here is 360 degrees. So I've got 60 over 360 because that's how much of the actual circle and degree measure I am looking at. Okay. Well, my circumference, so I can figure out based on my circumference the distance around my circle going all the way. I can figure out that length using circumference. Okay, but I want just that little piece of the pie. Okay, and that's what we're trying to figure out here. So I know my circumference formula is 2 pi r. So I'm going to use that. Okay, and that makes sense. Okay, so I'm taking the whole circle, so 2 pi r for my circumference, but then I'm splitting it up into a fraction here of just that portion, which is where that 60 over 360 comes into play. Okay, so I can reduce this a little bit. I know that 60 over 360 is 1 over 6. And then over here, I've got 6 pi. Well, this just happens to work out beautifully. That 1/6 times 6 gives me 1 pi. And we know that we're dealing with inches, so this is 1 pi inches. Leave your answer in terms of pi. You don't actually need to multiply the pi. This way it's more exact. So looking at this, we have a formula here for the arc length is going to be theta, which is any type of degree measure. Okay, that's how you denote degrees. So it's theta over 360 times 2 pi r. Okay, so that wasn't too bad. We have a formula. You just plug your information into your formula. If you notice though, this is based on degrees. If you wanted to actually make it even easier, you could simplify this and convert to radians. If you convert it to radians, it's your radius times theta. So this is in radians, and this one was in degrees. Personally, I think the radians is a little bit easier just because you can go back and forth between the two, but I'm giving you both just so you guys can see whether when you have degrees and when you have radians, which one to use, because they'll ask you within the different different contexts and different angle measures. Okay. Lastly, we need to go through the area of a sector. So if I got my circle, we're still working with that 60 degrees. I don't know. I just kind of like that 60 degrees, and we're going to go with 3 inches. So I got a 6-inch pizza, and I want to figure out how much pizza I am actually eating if I get a 6 of that pizza. So I'm looking for the area of that slice of pizza. So I'm just going to start you off with the formula right away. The area is going to be 1/2 theta r squared, where theta is in radians. Okay, so you're going to have to convert your degrees into radians here. So I've got my area equals 1/2. I need to convert that into my radians, so I know that it's going to be 60 times pi over 180, and then my radius is 3 squared. So now I can go through and just simplify this. Okay, so I've got 1/2, then I've got 9 here, 60 over 80, cross out the zeros and we get pi over 3. Then I got 9 over 3 gives me 3. Half of 3 gives me 1.5 pi. And we're dealing with inches. And because we're dealing with an area, it's squared. We're going to do another one of these just for good measure to make sure that we are okay. Let's say that my circle's getting a little bit bigger here. And my degree measure is 135. And my radius here is going to be 6 inches. So now my pizza's gotten bigger. So my area's formula is still 1/2 theta r squared. So I've got 1/2. I'm going to have to convert that 135. So I've got 135 times pi over 180. And then my radius is 6 squared. So I've got 1/2 here. And then I've got 36 on the outside, and I got to do my mental math here to do 135 divided by 180, which is going to be 3/4. So we've got 3 pi over 4. Okay, so half of 36 is 12. Is not 12, oh my goodness, is 18. Then I've got 3 pi over 4. So I'm going to go ahead and multiply that. And I got 13.5. Again, leaving it in terms of pi. So I've got 13.5 pi inches squared.